Alright, so skill practice 23 continued once again with Ben Jose and Parker Stevenson.
What's up?
Here we go! Alright, so question 5 continued. As I was saying, we're going to take out the valence electrons from nitrogen, hydrogen, and carbon. So we take 5 plus 4 plus 1 and add them, that gives us 10. So when we draw the dot structure, what we're going to do here is going to try using all single bonds, but that leaves us with 14 valence electrons, which is too many. So now we're going to try using one double bond. But because hydrogen can never have a double bond, we can only put the double bond on nitrogen. But that leaves us with 12 electrons still, which is too many. So next we have to put the triple bond on nitrogen, and it leaves us with the correct number of valence electrons. Because as I said, hydrogen can never have more than a single bond on it. All right, here we go. Let's figure out how many valence electrons we need for water. So for water, what we're going to do is we're going to figure out how many valence electrons hydrogen needs first. So for hydrogen, it's in the first column. So we take 1 and multiply by the subscript next to hydrogen, which is 2. So we multiply 1 by 2. We're left with 2 valence electrons for all the hydrogen atoms. And now we have to find all the valence electrons for oxygen. Because oxygen is in the 6th column, we take 6 and multiply by the subscript next to oxygen, which is 1. So we take 6 and multiply by 1. We're left with 6 valence electrons for all the oxygen atoms. So when we add that up, 2 plus 6 gives us 8, actually. Alright, so when drawing the molecule, we're going to use all single bonds for the water molecule, and that actually works. When we do this, it gives us 8 valence electrons, which is the right amount. So moving on to question 7. Question 7, ammonium. So in order to figure out how many valence electrons ammonium needs, first we're going to figure out, what column each element's in, multiply by the subscript. So for nitrogen, it's in the 5th column, and because it doesn't have a subscript next to its name, this means it is a subscript of 1, so we multiply 1 by 5. We're left with 5 valence electrons for nitrogen. Now we have to find the valence electrons for hydrogen. Because hydrogen's in the 1st column, we take 1 and multiply by the subscript next to hydrogen, which is 4. So we take 1, multiply by 4, and that gives us 4 valence electrons for all the hydrogen atoms. Next we add up the valence electrons from N and H, or for nitrogen and hydrogen. So we take 5 plus 4, and that gives us 9. But because NH4 has a positive charge, that means we have to take away an electron. So this is what we're going to have to do is subtract 1 from 9. So we're actually left with 8 valence electrons. So next slide. What we're going to do when drawing this, we're going to use try using all single bonds first. And when we do that, it actually works. It leaves us with 8, which is the right amount. So we use all single bonds. All right. So last question, I think. Yep, last question. CCl4. Alright, so what we're going to do here is we're going to figure out how many valence electrons each element needs by, looking at the column it's in and multiply by the subscript. So for carbon, it's in the 4th column. We take 4 and multiply by the subscript. And because there's no subscript next to its name, it's assumed to be 1. And when we do this, 4 multiplied by 1 is 4. Now we have to figure out for all the valence electrons for chlorine. Because chlorine's in the 7th column, we take 7 multiplied by the subscript next to chlorine, which is 4. So we take 7 multiplied by 4, and we're left with 28. And figure out how many actual valence electrons there are. We take 28 from the chlorine, 4 from the carbon, and we add them up. That gives us 32. And then when we use single bonds to draw them, it actually ends up working, and that gives us exactly the right amount, which is 32. Thanks for watching once again. Skill practice 23 with Parker Stevenson and Ben Jose.
What's up?